Okay, so I'm just going to do the first two questions from today's work. We need to take the equation that's already in vertex form and convert it to standard and factored form. Generally speaking, or for this moment, it's easiest for the skills that we have to go from vertex form to standard form. So I'm going to say y equals 2, and because I see that this is squared, I'm going to actually take a second and write that out like this. And there we go, minus 2. The next thing I'm going to do is I'm going to take this and I'm going to expand this expression right here using the FOIL technique. So I know that's x squared plus 5x plus 5x plus 25. And if you recognize that this is two perfect squares and you can do it using a shortcut, that's more than fine as well. So next I'm going to simplify by collecting my like terms. Next I'm going to break, I'm going to distribute 2 throughout. So I'm going to take my 2 term for my a, and I'm going to distribute that into all my a terms. So that's 2x squared plus 20x plus 50, and that's still in brackets. And lastly, I'm going to deal with that negative 2. And in class I kind of did this in multiple steps, but for now I'm just going to do it all as one. So I'll just rewrite it as broken out. So I now remove the brackets, and I can deal with the like terms of 50 and negative 2, and I say 50 minus negative 2 equals 48. And for our grand finale, there is our expression or equation now in standard form with 2x squared plus 20x plus 48. And this is kind of a necessary step to go to factored form. So with factored form, I'm going to actually use my standard form. So I've got y equals 2x squared plus 20x. That doesn't look like a plus at all. There we go. That's better. Plus 48. Yikes, I'm missing those plus signs a bit. So when I look at this, I can see that this is a trinomial, and I could factor it right now. But I know from class, and hopefully I've said this enough, that if I factor out a common term, it's going to make this a lot easier. And I know I can factor out 2. So y equals 2 x squared plus 10x plus, and I believe it's 24. So when I look at this, I have to think in my head, what's going to, and I'll just do my work down here, what's going to add to positive 10 and multiply to positive 24. And I could list through the all the different factors of 24. And I get probably something like that. And I know that if I add 4 and 6 together, I'm going to get 10. So the next thing I'm going to do is say y equals 2 x plus 4 x plus 6, and there we go. It's now in factored form as well. So there's factored form and there's standard form. So this time I've given you something in standard form. Last time was in vertex form, now in standard form. And it's asking you to determine factored and vertex form. So again, we don't really have the skills at this moment to go directly from here to vertex form, but we will in a bit. But for right now, let's go ahead and factor this. So I'm going to say y equals 2x squared plus 12x plus 10. I know I can factor out 2, so I'll write 2x squared minus 6, plus 6x plus 5. Next I look at our equation, and I'll just kind of do my work down here, and I'm going to think to myself, well, what adds to 6 and multiplies to 5? I know that's 1 and 5. And I can kind of just jump right to that for our answer and say 2x plus 1 x, yikes, x plus 5. So there's my two factors. I don't know if I'm going to have enough room to do the vertex form, but we'll see what I can do. So to find the vertex form, I have my two zeros of negative 1, 0 and negative 5, 0 for my factored form. So what I can do is I can find the axis of symmetry with that. So I can say negative 5 plus negative 1 over 2, and this is going to give me my x value, or what we can also know as our h value. And I can also clean this up a bit to make x equal negative 5, and positive times a negative makes a negative, so there we go. I know that's negative 6 over 2, and now I have my x value being 3. Sorry, negative 3. So when we look at the vertex form, we've got y equals negative 3, which we don't have that yet. We have, let me step it back a bit. We've got an a value over here that we were told, and the way a value here and here is still the a value that we can have in vertex form. So that's going to be 2. We know it's x minus, and then we'll put in our negative 3 value, and that'll help explain why our sign is flipped when we are in brackets. We got plus k. So the next thing I'm going to do is I'm going to say y equals 2x plus 3 squared plus k. So how are we going to figure out k? And hopefully in your head you're thinking substitute in a known point. And I hope that when you look at standard form, in your head you think, wait a minute, there's a known point there. What does this 10 right here, C, tell you? And C tells you your y-intercept, which is a known point. And I believe that known point is 0, 10. So we can take the 0, 10 and substitute it in, and I'm just going to do that work over here because I'm kind of short on room down below. So I'm just going to say y equals 2, or sorry, not y equals, let's clean that up a bit. That's going to be 10 from my y-intercept, so 10 equals 2 bracket 0 from my y-intercept plus 3 squared plus k. And now we can isolate nice and neatly for k. So I know my next step is going to be 10 equals 2, and what's 0 plus 3 is 3, and that's squared is going to make 9 plus k. Next I can do, and let me make myself a little bit of room down here. Can I even erase this stuff? I can't. That's too bad. So I'll just kind of keep working here. I might make a bit of a mess. So I know that 2 times 9 equals 18, so 10 equals 18 plus k. Sorry, but my math's not lining up. I'll subtract 18 from both sides. These cancel out. So now I know my k equals negative 8. And I can now plunk that into my vertex form here of y equals 2x plus 3 squared minus 8. And there we go. In factored and in vertex form.